Okay, so let's start with the Muller method. Now first you have a polynomial, so f of x is equals to, say for example, x cube minus 13x minus 11, something like that. So you have a polynomial, so this polynomial has a curve. You can check the shape of the curve using MATLAB. I have not checked, you can check it by yourself. Now for now let's just assume the curve looks like this, okay, something like this. So this is my polynomial. I want to find the root of this polynomial, okay, and from this one the order, it has order of 3, so you can understand that the number of root it has is equals to 3. Root is equals to 3, that is the number of root. Okay. So the number of root is actually 3, and since the order is odd, we can say that one root among them must be a real root. Yes, sir. It must be a real root. Other two can be real roots or can be a complex root, complex conjugate roots. Okay. So we don't know. We have to find it out and we have to figure it out. So let's assume that this is the real root. Okay, this is the real root of our function, of this polynomial. That is what we want to find out using the Muller method. So what we do in the Muller method first is assume 3 point. We assume 3 point. Okay. Assume 3 point. Let's okay. Let's name them as x0, then x1 and x2. Okay. So I assume 3 point. Now say if I assume 1 2 3, this is like 1 2 and 3. So this is my x0, this is my x1, and this is my x2. Okay. So I have assumed 3 point. Okay. Then what you want to do in the second step? I want to calculate f of x0, okay, then f of x1, then f of x2. That means this is my function. I want to find the value of the function at this point. So it means that at this point the value is, if you check it like this, this is the point and this is the point, okay, and this is the point, this is 3 point. So this is the value of the function at this point, okay, at this point. So this is f of x0, then this is f of x1, and this is my f of x2. Okay, so the second step is done. In the third step, what you want to do here is find the parabola. I want to fit the parabola, okay, that goes through those 3 points. Okay, so I want to find the parabola that goes through this 3 point. Okay, now let's just, for easy to draw, so let's make it something like this that I can draw it easily. This one is my f of x2, this is my f of x1, this is my f of 0. Okay, so this is my 3 point. Now I want to fit the parabola like this. So this is my parabola coming here, coming here, coming here, going like this way. I want to find the parabola. What does it mean by find the parabola? So you know the equation of the parabola, that is ax square plus bx plus c. Okay, I have to find the value of a, b and c, this 3 point, based on this that goes through this 3 point, f of x1, f of x0 and f of x2. Okay, so I have to find the parabola means I have to calculate somehow a, b and c. We'll look into that in a little bit later, how we can find these things. Okay, so I have to find this 3 point. So once I find this 3 point, that means I find this parabola. Okay, in the next step number 4, I calculate okay, I have roots of the parabola. You don't have to calculate. Okay, I'm going there first. Okay, so once you find the parabola, I am interested in this 2 point where it is actually crossing my x-axis. Okay, I am interested in these 2 points. Then I want to see at which point the curve is closer to that. Now you can do it in one way. The way it is shown in the book, or that is actually described in the Muller's paper, the paper on this. Muller is a scientist who wrote this paper on this Muller method. It is shown like this, that x is equals to, as you know, minus b plus minus root over b square minus 4ca divided by twice a. Okay, this is the root of the equation. That means this equation should give you this point and this point. But this has some problems with the round of error. Okay, this is discussed in the early chapters in your book. You can check. We'll use a different equation, the same thing, just a different representation. It is like this way. X is equals to, we take 2c, okay, 2c divided by b plus minus root over b square minus 4ca. Okay, we'll use this one to find the roots. Calculate now. Okay, let me find the roots. Okay, so if we come here, from this equation there is a plus and minus. That means I'm going to get two values. So let's name it like this way. This is x1, no, not x1. We have already used x1 before, so let's name it r1 and r2. R1 and R2. So two roots. So which one should I take? Okay. Now what we can do here, there is a condition that is given. That is, if this b plus this portion, that is the determinant, okay, this portion, then take the absolute value. Okay, if this one is greater than b minus this whole portion, okay, the one which is greater, I will take that one. If plus, if the I want to take the larger denominator, simply put, I want to take larger denominator. Okay, larger denominator. Okay. So whichever one is larger, b plus or b minus, the one that is larger will take that value. So from this I will get only one. Okay, let's keep it the name r. Okay, so that is my root of the parabola that we just found from the 3 points. Okay, let's come here. Okay, so this is the 4 approach. I have found the root. Now once I have found the root, what I'm going to do, I'm going to go to the next step. That is, I want to find the next point. How do you find the next point? So let's name it find next iteration point. Okay, so the next iteration point, so let's name it x2, no sorry, x3 will be equals to x2 plus that r. Okay, the r that is calculated from this one, this step 4, I'll just add it with my x2, so that becomes my new point. Say, let's say this is actually present here, somewhere here in x3, somewhere here. For this point I have this point, something like this. So let's say this is my x3. Okay, so once I find the next iteration point, what I'm going to do, I'm going to calculate number 6, calculate error. What is the error? The approximation error. So I am going to calculate epsilon a, that is equals to my current approximation, my next iteration point is x3. This is the point that we found, minus x2, that was our previous approximation. x2 divided by x3, okay, to get the relative approximation error. Then I take the absolute value and use it as a percentage value. So I calculate the error to use it as a tolerance value. We'll look into it later. So what do we have now after this sixth step? After the fifth step, I have calculated a new point. Then what I'm going to do, 7, okay, assign new 3 points. Okay, so what I'm going to do now, I will going to just simply forget about the first one. I will remove this one, and I will take this one, and this one. So my new 3 point is x1, x2, x1, x2, and x3. Okay, so this is my new point. After finding these new 3 points, I'm going to go back and start from level step 2 again. I'm going to go to the next iteration. I'm going to calculate these things again, f of x1, f of x2, and f of x3. Then I'm going to find the new parabola that goes through these 3 points. I'm going to find these 3 points, new parabola. Okay, that means I am going to find this new ABC. Then I'm going to find the roots of the parabola. What are the roots? Okay, I will take one of the roots based on the equation that is shown here, based on this condition. I will find the new point, then find the next iteration point. Okay, using this one I'm going to find next iteration point. Then I'm going to calculate the error, new error, the new value that I found minus the last value that we found, that is the error that I am calculating. Okay, so this EA is supposed to decrease after each step. Then I am going to find the new 3 points. Then I am going to start iteration again. Then I go back here again. Okay, so this is the step. This is the process that we are going to calculate. We are trying to iterate again and again and again. So after few steps, after few iterations, you will see that it is trying to converge to this point. Gradually, it will try to converge to our destination. Okay, and this way you can find the real roots as well as the complex roots, because as you can see, I am using this sign. So that means I am actually handling the I am actually taking into consideration the complex roots as well. Okay, so in the next lecture I'm going to show you an example, so that will make it much more clear.